Totally not on the verge of losing it after I just redid this whole thing and it did not work. And now I have to redo this entire problem for the 47th time. Ahaha. And my screen is glitching. Anyways, we're going to be learning about the probability of independent and dependent events. Basically, I'm not even about to redo this anymore, okay? This is the equation that this man gave to us, okay? So it says Randy has 4 pennies, 2 nickels, and 3 dimes in his pocket. Randy has a lot of chump change. If he randomly chooses 2 coins without putting them back, what is the probability that both are dimes, okay? But before we can even solve this, we have to know what our independent and dependent events look like. And basically, to explain, is that independent events are events that don't really change the outcome of the probability. I think that's how I will put it. So basically, let's say that Randy did in fact put these coins back, and every time that he drew 1 coin, he put it back into his pocket and did this over and over again in a singular loop. That would not change the probability because Randy is always putting these things back, so it always has an equal chance, right? And then for dependent probability, that's kind of the opposite of what we're dealing with. So if you don't put something back, that's obviously going to affect the outcome. And it's kind of like the practice problem that I did earlier with the towing of the cars that I looked at. And if there are 10 cars in this parking lot and 2 of them are going to get towed and 1 of them do, well, the total number of cars that are getting towed, well, the total number of cars is going to change. So that automatically changes the outcome. But you still have 2 of them. So, yeah, it's somewhat something like that. And, yeah. So, that's why we're gonna go back to AutoDraw. And we're gonna hope that everything works. And, so, then we're gonna draw our pennies. These are very huge pennies. Do not ask why. There's 1, 2, 3, 4 pennies. And then we have 2 nickels. And then we have 1, 2, 3 dimes. And since it says that we're going to be looking for the probability that both of them are dimes, we're not going to pay attention to the pennies just because of that. And we're also not going to pay attention to the nickels because of that. And we're mainly only going to be looking at the section that has dimes in them. Because there are 1, 2, 3 of them, and we want to know the probability that another one is being taken out of there. So, now that we know that, and I've re-explained it, and we know that this is a dependent event, we can talk about our A and our B and what they equal. So, and now that we know that, we can already write our kind of like formula, and it's that the probability of A times is the probability of A times, that is a very interesting star side, times the probability of B, there we go, probability of B, after A. And basically what they mean by after A is that when we have our 3 coins, which we can write as a fraction over here, our 3 coins out of the 9 coins in total, and after we take 1 of them away, we're going to end up with 2 that we have, and the total number of coins decreases. So, that is the change. Like, B after A. Okay, so after A happens, this is going to be B. And that's pretty smart. Honestly, the mathematicians did their things with that. But anyways, time to set this up as an equation. So, we have 3 over 9 times 3 over 9 times 2 over 8. It's a little lopsided, but I hope this is okay. And then this is the part where we'd cross-reduce, but unfortunately, we cannot cross-reduce. And that is mainly because the only, like, numbers or, like, terms that 2 and 9 have together and 3 and 8 are technically 1, which are not very helpful. So instead, to make things more simpler without having to do all of the craziness and make this even more complicated, is we're just going to times across, because times across is the easiest way to do things, obviously. And anybody who says otherwise is obviously lying. And yeah, that's why the mathematicians are wrong. But anyways, so 3 times 2 is going to give us 6. I finally said that right. And 9 times 8 is 9 times 8 is going to give us 72. Okay, big numbers. So now that we know we have very big numbers going on in this, we are going to have to simplify, because 6 over 72 is not in its simplest form. So that is going to give us, once we simplify this, that is going to give us 12 over 1, I hope. And yeah, that's basically all there is to it. And that is probability, or that is the probability that the next dime is going to be this number right here. And so yes, okay. And yeah, math is Candy Crush, like I said before, and hopefully this video will go through and I don't have to record it for the 3rd time over again, because I really don't want to. So yeah.